Thanks again. Again, my name's Scott Alford. Came from Arizona, and the weather's just about the same as here. It's a real honor to have an award like this, and I'm really, really proud of my team. They've worked really hard. They strive to continuously improve. This is a photograph of our team that we took this year. Every one of those guys are there's a couple guys missing, but they're all certified infrared thermographers. They're all been through the acoustical program, and most of them are working their way through the vibration program. On top of that, we're dedicated to a great amount of training as far as like lean practices. Our company has an internal process where we go through this, what's called the BIU, and every one of them are enrolled in that, working on how to figure out better and smarter ways to do our job and be efficient. So this team, just talking about how we filled this team and what we're committed to, you know, we have no really, when we go to staff on our team, we're looking for unique people that are dedicated to being better, guys that have done really good at where they're at, but we're not looking, we haven't closed our doors to any certain kind of a person. You don't have to be an engineer, although we don't mind having those around. We've got a couple of journeymen, we've got some electricians, we've got even an accountant that came through our system that's turned out to be one heck of a predictive maintenance guy. So we haven't closed ourselves in on who we're looking for as far as how we make a tech. It makes for a really long training process, but again, that's what we're really most proud of, is how dedicated we are to training. So how do I move this thing forward? Again, Arizona Public Services is the largest utility company in the state of Arizona. We are a subsidiary to a parent company called Pinnacle West. Pinnacle West owns several other companies, some of them in real estate, some of them in solar. We've got all kinds of different companies there, but we do roll up to them. Our company is, again, the largest. We cover that area in Arizona, which includes the greater part of Phoenix, Arizona. There's some statistics, but we have 1.2 million customers right now. We have 415 substations, although we just put 2 on since the slide came out. 28,000 miles of distribution line, which we get in our program. We get all of that scanned and with an infrared and a Daycore camera once at least every 9 years. So, and then we've got 5,000 miles worth of transmission line that we get scanned with Daycore and infrared on about a 4 to 8 year interval, and then 54 generation units. At Arizona Public Services, we have 2 predictive maintenance teams. We have one that works in the generation team, and they've got kind of a different configuration, and then we have the T&D, and I'm speaking on behalf of the T&D predictive maintenance team. So this is a map that illustrates part of that, the mileage on the high voltage line. This kind of gives you an idea of what we're up against. We have a maintenance basis that dictates when and how much of this line we're going to scan. We have some successes on the finds. It's the transmission lines that we have are in really good shape. It's rare that we find something, but we do find something every year. We pride ourselves on communication as far as what we find, how we find it, when we find it, and get it to the appropriate person. And we have a system for that, and I'll talk about that a little bit later. So when we talk about the map that you just saw, this is sort of a breakdown of it. Almost 2,000 miles of 500 kV. We get that every 3 years. We get the 805 miles every 3 years of 345. The 230 and 115 we get every 5 years, and then we get the 69 on an interval of about, depending on some 69 we won't get for for the 8th year, but we get most of it every 6 years. And because there's so much 12 kV underbuilt, there's a little bit of overlap on that. So some of the challenges that we have from a team stand, there was 9 of us we're waiting to fill a vacancy, and then we face a whole bunch of challenges. Right now we're a lean team. We cover a whole lot of area in Arizona. We've got several different technologies that I'll get to, but one of the challenges is that we're expecting our peak demand to go up. You can see by 2020, which doesn't seem like long ago, but it doesn't seem like we've been in this business as long as we have. We're going to be up to 9,000 megawatts from 7,000 as we are today. But we've seen the exact same growth since 2000 when we started this department, and so we're hoping to, by everything that we're finding right now at the moment, we've got a real good idea of what the condition of our equipment is, and that's going to be a real important thing to our team. We understand that it's not going to be so hard to take that next 2,000 megawatt step up as it was to take the last, because we really struggled. We had a real big failure in 2000, and it was actually about 2000, 2001. It happened on the 4th of July. And at the time, that's when APS made the real commitment to predictive maintenance by just basically they'd hired me, and all it was a camera. And as a result of an investigation and some of the things that we found on the failure, which incidentally was 500 kV transformers. They were single phase. They burned to the ground. It was catastrophic. We brought in EPRI. They gave a bunch of suggestions. We put on Wes at the time and another technician called Bob, and we were kind of a subsidiary of another department. We just sat there and worked under that. Our department became what it was in the photograph after a few more years, when we realized that we had a good sample for what the three guys could do. We put together kind of a proposal, and our vice president, he said, yeah, that's a good idea. So as our load goes up, we have a plan till 2027 from a projected resource plan. We're kind of working with some of the pressures on our company to use some of the renewable stuff. You can see that we're not going to go up in nuclear. We can't get permitted. We're probably not going to go up in coal. If we do anything, we'll go backwards in coal. But right now, we show a little bit of growth. But you can see that natural gas and renewables are a big part of where we're headed from where we are in 2012. But one of the things that we deal with is our customers in renewable energy, and we're just starting to deal with our customers from a predictive maintenance standpoint. So safety first. In our department, we take safety seriously, and I've got 2 slides to talk about safety and what it means at APS. But we keep a running stat. We've never had an injury since we've been a department. We haven't had an injury even as a part of a prior department since 2000. But we've basically driven over 325,000 miles without an accident. Every one of our guys drives statewide every day. We haven't had an accident at all, so 1,100 days. We've got 100 years of combined accident man-free years. We've never reset the clock, which is a big new issue with our company as far as even if you have an event that could have been an accident, we call that a clock reset. Our department's never reset the clock, and I think our whole company had 26 clock resets in the year of 2012 so far. We found 1,257 hotspots as a team, 380 of those this year. And I don't know how many of you are familiar with the T&D and how broad it is to try to organize, but we do the switch yards and the generation stations. We do every single substation and all these power lines. It is a real effort to coordinate it, and I give that to Wes as to get what done and when we're going to get it done, because we make a really large commitment to what we're going to try to get accomplished in a year, and we've got pretty lofty goals. We stretch on those goals for sure. We keep track of cost avoidance, and we're happy with what we do with our cost avoidance. We'd like to think we're kind of conservative. This month alone, we've had $300,000 worth of cost avoidance, and year to date, we've had $5 million of cost avoidance. We found a really nice transformer at a generation station pump that had a oil pump that was getting ready to completely fall off. They haven't taken it out yet, but they have disconnected it, and without any doubt, that pump was in failure mode. And then we figure we've probably averted 380 unplanned outages. So again, with the safety, we set a goal or a target or a commitment of having no accidents, and then we continue to do it safe, or we don't do it at all. I don't have a problem if somebody that's working for me says, no, I don't want to do it because it's not safe. We had a feeder that was down on the border of Mexico that probably 2 weeks prior to that, Border Patrolman was shot, an agent was shot and killed there. It was right on the same feeder line. We decided not to scan that line, and we're going to go ahead and proceed with that in 2013 with the Guard. That's just one example. I mean, it's easy to say, well, it's not going to happen that way, but we're not going to put our guys in any harm's way. Our inspection truck looks fairly suspicious. I think down there could be perceived as something that it's not. And I'll have a photograph of that and we could talk about it. But it has cameras on the roof, and we just wouldn't want anybody to think that it was something that maybe with Border Patrol or whatever and have them feel threatened. So, or from an organizational standpoint, this is our for energy delivery. You see that we've had 20 recordables this year. I mean, we have a goal of 0. Everybody would like to have a goal of 0, but unfortunately, we've had 20, and those are just, we haven't had anything serious this year. We had something serious last year. And then from an energy delivery standpoint, I think we've reset the clock 23 times. We've got a unique organizational chart, the way we flow. The section leader, in this case, typically at Arizona Public Service, a section leader reports directly to a manager that reports to a director. In our case, we set this up so that the Pdm, myself, reports to a director and then works directly with all the managers of several different departments to provide a service. And the reason that we feel that this is effective is that, for one thing, we're doing work in transmission, we're doing work in distribution, and we're doing work in substations, and we don't want there to be any kind of a conflict. Not that there would be of interest, but we get a little bit more weight when we're reporting up that way. We've never had to use it. We report just exactly the way we would report. And then, again, there's the layout is we've got all the technicians working for us. We have an admin coordinator job that's posted on the board. And then a couple of journeymen that at our company, there's some equipment that without a journeyman, without that credentials of a journeyman, we're not allowed to go into some certain areas or open some certain equipment. So we would have our journeyman accompany us on those kind of inspections. But for the most part, everything a predictive maintenance technician can do. And some of our predictive maintenance technicians are journeymen, just not all of them. So the process that we follow is in this flow chart, but it basically is talking about Maximo, which is basically our software that we use. It's the new web-based IBM software, and we've had some challenges with it, but it's just a flow chart that kind of illustrates the flow of a PM. Everything we do is planned. We do some unplanned stuff, but that would be a call out. We have some equipment, and it's coming in the slide. We can kind of talk about how that works on a call out, but we typically are 100% of our work is planned maintenance, with the exception of, can you come out and reshoot something that we fixed? Can you come out and maybe do a portable we have a portable DGA unit. We saw something, can you come out and take a look at the transformer? So our targets has little to do with our KPI goals and indicators. Our targets basically focus around a few things, and that's we want to reduce our unexpected outages, and we want to collect baseline data, and all of that helps us be able to tell my director or manager or my boss or anybody else, as much as we can about the condition of the equipment. That's basically what the vision is. If my boss asks me about a transformer or a breaker, I want to be able to give them a good answer. So we keep as much good information, as comprehensive data, and make it clear and concise as possible, so that when asked a question, we can answer it with real information that's useful and information that is complete and comprehensive, using as much technologies, including visual inspections, that we can. We do that. We have a special software for that, where you don't necessarily have to be in the same place in order to put in information. So we've got a couple of visual inspectors that work outside of my department. They have access to this. They can write a report. They can put it into the program, the PDIQ program that we're utilizing, and it would be bussed together to where, and if we wanted to pull up that piece of equipment, we'd get his input on the condition also. Speaking of key performance indicators, the next few slides talks about our commitment and our goals and the things that we intend to do every year. It's important to us, it's important to my boss, and sometimes it puts a little bit of pressure on us, but it's a continued effort for me to make my team understand that we don't have to necessarily achieve these numbers. I feel like sometimes we put pressure on these guys to achieve these types of numbers, and if they think they have to do something that is outside of being completely thorough and comprehensive and give us good data, I'd rather them not miss one or two of them than not give us the best data. And I think every one of them understand that it's okay not to get these things done. It might take a great deal of time to go through this. I can also email you this if you want to take a look at what these goals are, because I know it's probably really small, but it just basically talks about how much and when we're going to do some of this stuff. So again, we have the same type of goals on our overhead lines. Talks about how much and how often. The 12 kV lines, it shows here that we're going to do it all, which is about 12,000 miles to date in about 10 years. We're on track to get it all done in about 8 years. And then it also shows our commitment to all the other voltages and what our strategy is. We've got some other, in order to make this happen, we do most of the higher voltages with the helicopter. And so from a budgetary standpoint, we've got to be strategic and have about an 8-year plan as to what we're going to do and when we're going to do it in order to get it all done, with some of the overlap and some of the differences in annual inspection times versus voltage. So again, key performance indicators it's just the way it is, and it does drive a lot of the things that we do. It has to do with setting goals and achieving them, being successful, and my boss definitely cares a lot about this. We are not afraid of falling short. Again, to us, more importantly than achieving in all of the entire key performance indicators is making sure that these guys are getting the best information and communicating it as good as possible with good, clear reports. I would rather them be thorough and fall short. And they're good at communicating if they do fall short, and it allows us some time to reallocate resources and get done what we need to get done in a timely manner. So as a team standpoint, we can still manage this. So here's some of the tools that we're going out there and some of the tools that we're using on a day-to-day basis. Infrared, corona, vibration, ultrasound, acoustical SF6. We've got the portable DGA unit. We've got a digital fault imaging system, an AMS-8, which is made by the 555 company. It's an 8. They didn't make a whole lot of them, but 555's been bought out by Physical Acoustics, and they have a new piece of equipment that I think we're going to probably buy that's got 16 channels on it, and it'll probably replace the 8-channel sound detector. And that's a set it on and leave it type of equipment that allows us to monitor equipment when we're not there at a certain threshold. Works really good with regulators, works really good with tap changers, so that you can kind of get a measurement of the sound when these things are stepping up and changing levels. Sound level we take on every transformer. We use some partial discharge stuff. We have a ground grid testing system that I've got some more information on. And then we do all of the RFI, radio frequency interference investigations for our company also. That was something that we just inherited, but we've stepped it up. We've improved it. Our company's doing a great job. Our customer service is excellent on that. And I know for sure that since we've taken it over, we're able to give better answers to our customers than they were getting prior to us taking it over. And that just comes from to give the credit to the technicians and the staff that work in that area, because it's dealing with customers directly. From our line survey standpoint, we talked a little bit about that. We do find things. We use the company helicopter, which is not any longer the one shown below. We use a contractor helicopter, but we have a lot of good successes. The team, again, so much of this, and just to keep going back to communication, the team that fixes it does an outstanding job. They're open to what we found. They weren't always like that. You know, we went through about a 4-year battle with almost every one of our customers, which is all of the O&M teams, whether it's substation, whether it's a distribution team, or whether it's these guys here, the hot stick transmission repair teams. We haven't always been their best friends. They haven't always believed in us, and we had to go through some turbulence. But now we're working hand in hand with them. They enjoy what we do. They appreciate what we do, and they definitely get out and address the things that we find. And it's never really been about whether their manager or director made them or required them to do it. It's been about the fact that the things that they're finding are there, they're very real, and there's no doubt that in most cases we've averted some outages. So this is the inspection truck. This is a vehicle that, if seen down on the border, would be a real threat to the people inside of it, I'm sure. We're very proud of this. It's a cutting-edge vehicle that we had built 2 years ago. It takes care of infrared, corona. It has a nice visual camera on there. The acoustical, we put an acoustical monitoring device on there that didn't work, so we took it out. And it does more than 1,400 miles per year, and it's important to understand that it found about 330 issues on our distribution lines in the state of Arizona this year. And of those 330, is that a right number, 330?
Next one.
Okay. Of all the fines, remember, if you find 330 fines alone in this vehicle, you've got to communicate what we're going to do about it, what a strategy is, to several different maintenance docks. It's a real challenge because in the state of Arizona, we have 9 maintenance docks out there, and every leader has a different outlook and a different approach. Some are more efficient or effective than others. Some are more technological savvy than others, and some are more accepting than others of the services that we have. So for every report, it's just more and more hours. These guys work really hard. They find a lot of great things, and without any doubt, they definitely have improved our reliability as a company entirely. Last year, our SAFI indicator and our CADI indicator, and every indicator that we have is better than it was the year before, and the year before was the best we ever had. So that would make this year, we're on track to have the best year that we've ever had as a utility company when it comes to how reliable our distribution system is. I don't think that we can take all the credit for that. I know that everybody's working hard to be better in our company, but I know for sure that this piece of equipment has played a key role in that. And I know for sure that the training and the expertise of the 2 people that operate this vehicle has played a key role in how successful this vehicle is. It has 0 downtime. We have it down at the moment because we're replacing some cables, but for the most part, it is very reliable as far as the date. When we have it out there working, it's out there, it's inspecting, it's finding issues, and we come in and we report on them. Here's a summary of how that thing did. Total, it's got 799 in about 2.5 years, hotspots. And of those 799, 540 of them were in a severe criteria. Our criteria for what is severe is a little different than most because we're in Arizona. We put some extreme pressures on our system in the summertime. In order to be a severe hotspot, priority A, you're over an absolute temperature of about 95 degrees Celsius. In some cases, we've seen 1,200 degrees Celsius on stuff. So we've had rolled up and found stuff dripping off of poles. And that's a breakdown of how it goes from year to year, which is pretty equal. And it makes sense that even the half year is almost as much as the other complete full years, because initially when you start hitting things with infrared, you're going to find a lot. We're looking for several things with the camera. Again, the Decor camera, there's a picture of the head of the vehicle. These are handheld cameras. We looked at some of the options when it comes to built-in everything, do it all yourself, and we felt that this was a better option to go this route. But there's a visual camera in there. Again, there's the infrared camera on the left, and on the right is just a regular Decor made by the Ophil company. Loose connections, faulted insulators, bushings. We find a lot of leaking arresters, splices and transformers, and on occasion a variety of other things. The hotspot up there on your left, incidentally, is a hotspot that came off of our Harbor substation feeder, and it fed the Army National Guard on a radio feed to Sky Harbor Airport. It would have not been good. I think, if my memory serves me correctly, that thing was running at about 900 degrees Celsius. So, from a substation standpoint, again, we've been in our substations quite a bit longer, but you can see 876 of those are critical. We have a little bit of a different criteria for substations than we do our distribution line as far as what we allow in our allowable temperatures. To speak a little bit of our criteria sheet, which isn't listed in here or showed in here, it's all an automatic sheet where, in order to have a lot of consistency, because that's another thing that's important for us, is that everybody is consistent. It's just a sheet that automatically calculates a criteria when you just put in the ambient temperature. You just fill in some of the basic infrared details, and it'll calculate the criteria for you. So we have 3 or 4 different criteria sheets depending on what we're looking at. And in this case, I just wanted to recognize that from a substation apparatus standpoint, whether it's 1200 amps or 600 amps or the distribution, we have separate sheets for those. In this case, we have 876 priority A since we started this. 38 of those were in 2012. It's fairly consistent. There is a spike there where we had 3 guys working. We'd stepped up our maintenance basis in 2006, 7, and 8, where we were doing quite a bit more scans, and we're a little bit more dedicated to that. So our Corona, there's a look inside of the vehicle. That's, if you look inside of the Suburban that you saw earlier, there's a picture of what it looks like inside. And again, it has a Corona camera. It's got one screen for a visual. This guy has a wide-angle shot on the visual, and in the center, he's going to be operating with the joystick the infrared camera, and then he can also operate the Decor camera. There's a separate control for that, but most of it is self-adjusting, and so that they can just keep it going directional. Again, I think it's a pretty nice view of what the inside of that thing looks like. It is a cutting edge piece of equipment. Inside of it, there is not a generator, but it's a generating battery system. There's 2 batteries under the hood. This thing can operate with no car battery at all for 3 or 4 days before it would run out, and it still continues to generate itself. So, from an acoustical standpoint, we've got several UE1000 or UE15000s. They help us with the radio frequency. They look for insulator damage and corona detection, but we use them more for leak detection for nitrogen. If we have a transformer out to find nitrogen leaks, we use them on bearings, pumps, and some of the motors for the transformer oil pumps. And then we also do a little bit of work with the vibration on the high-pressure oil filled system. We do some of the work on that. Here's some of the other equipment that we have, a sound level meter. We've got this Ultra-Tev. We haven't had a whole bunch of anything with that, but we have a couple of them, to be honest with you. And there's the picture of the 8-channel box. And then there's also a picture of the new Sensor Highway 2 that we're kind of putting into place that does some triangulation stuff. It's a physical acoustics thing. Vibration, again, we do find value in vibration on the tanks of the transformer, although it doesn't give us a whole lot of information. It's not acceptable for most of them to have a lot of vibration. It deals with lower frequency stuff on transformers, loose blocking, deformed windings. There's a reason why a transformer is vibrating, and so there's no direct science behind it. It's just a watch list item, but we do take vibration on every one of our transformers, and it is always really, really good information to complement some other technologies, primarily in this case dissolved gas and analysis. So if we have something going on and we have some vibration, we have to put that together and try to come up with some of the answers. We've got a big SF6 program in our company. In our company, we've made a real big commitment where we've got 2 of the handheld cameras that you see on there, and then one of the older ones over on the left, which is a laser camera. APS made a big commitment to stopping and reducing our SF6 leak emissions. And when we started looking for leaks back in 2003, we were one of the worst utilities, I think, that were mentioned on some reports that said, you know, these guys have, this is what your capacity is, this is how many pieces of equipment that you're using it in, and this is what your leak rate is. And since 2003, we reduced our consumption, how much SF6 we purchase a year, by 96%. We reduced our leak rate, which was at one point 28% of the SF6 gas, that is versus the capacity, to less than 2%. And more importantly, it's been about $1 million of gas that we save per year since 2003. Those are real numbers. That's not a. It's just what it is. We find leaks, we come up with a strategy to fix them, and we go out and we take them out and we make the repair. In some cases it can't be repaired and it has to be a breaker replacement, and in other cases we use some of the either rebuild it, tighten it, or we even clamp and pressure shoot it, which I'm not fond of, but in this case, that's what we had to do. The photograph there where they're taking a shot of it. We have a borescope. We use the borescope on occasion. Basically, we do internal inspections. The last thing we did was go into a gas-insulated bus. Engineering wanted to take a look at something inside there, and in order to get in there and take a look at it, they would have had to have taken it completely apart. We were able to go in there and give them the answers that they needed. We've gone in and found faulted ground in transformers. We've also done some retrieval. We took a washer out of, they got dropped into a 500 kV breaker. We pulled it out. We pulled a bullet out of a transformer that had been shot. So the guys, it's a very difficult piece of equipment to operate when you're talking about retrieval, but they've somehow figured out a way to get in there and get those things out of there. We do have a grid sense inspection piece of equipment. This is a camera that goes on a hot stick. The service that we provide to our customers is, you know, if we have some corona, we like to do an inspection with this also, because that way we can say, look, the insulator's cracked. Here's a photograph of it. There's no way you're going to take a picture of that on the ground. Nameplates, we do have some bushings out, some really, we're trying to clean up our Maximo database and give the best information in there, but we've got some bad information as to what bushings are on what transformers. And so we get a list of bushings every year, and we go out with this piece of equipment and take a photograph of them and verify that what they think is on that transformer is actually on that transformer. And we're really concerned about a kind of bushing that we're trying to take out of the system right now. So we believe we've got them all removed, but we're out still looking to verify that the bushings, if there's a deviation in our Maximo database as to what bushing is, this is a piece of equipment that we're operating. Again, the portable DGA unit, the value in this piece of equipment allows us to get good information on a transformer. At Arizona Public Services, we've got 9 visual inspectors that go out and they're taking oil on every transformer. We have our own DGA, dissolved gas lab, and they do all of that in the chemist lab. We have 2 chemists that are working in there. But when a transformer sees something, an irregular voltage or some kind of a fault or a suspected fault current event, we can mobilize this unit, and the technician, when he gets there, can pull oil and give us a good DGA within 30 minutes. Going back to that fault at West Wing, had we had this piece of equipment, I think that fault wouldn't have happened. Back in '99, when that transformer failed, if we would have been able to pull the gas and analysis right there at the time, I think we'd have seen something inside of it that would have said, no, we don't want to re-energize it. Before we re-energize any transformer that's seen something kind of a fault, we'll go out and we'll take a look at it with this piece of equipment before they'll actually put it back into service, which saves a lot of time. And then we'll still send one over, an oil sample to the lab to make sure that they're getting the same results. Every sample that we take with this, we'll send a twin over to the lab to be sure that it's right, to double check it. And we've double checked over 100 samples with the lab, and there is a good direct relationship between our results that we get with this piece of equipment and what our lab has. We also have a lot of online transformer DGA monitors by the company Serveron. So I think with any program, and again, we feel like with our program that communication and reporting is probably what's going to make us or break us as far as our successes and how well we do. Basically, just a slide that kind of shows that we give 4 deliverables. Our analysis, we do troubleshooting, and we do reports and condition monitoring, and we help to make some decisions because that's really what we want to do. So we acquire it, we acquire the data, we come up with the information, and then we try to give some solutions for corrective actions. But communication is probably more than 70% of the issues, even though that's what says on the slide. If we can't get the good information to them to get them to understand what we need to do, then we find that some of that stuff, either it won't get done right, or it won't be as timely as it needs to be. So we look at criteria. Again, we've got 4 different types: critical, serious, intermediate, and minor. A minor would be more of a watch list, but we had a criteria 1, 2, 3, and 4. We had to change that for some reasons that the new Maximo came out, so we went to an A, B, and C method with a watch list. So we kind of have evolved with what we do with the criteria, but we, like most companies, have 3 or 4 different types of criteria. From a report standpoint, on the right is just a basic what an infrared report looks like. One of the things that we strive for is consistency, so we use the same template. We want every technician to kind of use some of the same palette. We want them to use the consistent format, and we want because our customers are if they're used to looking at something a certain way, we feel like they'll receive it a whole lot better and they'll get a whole lot more done, and we'll be a little bit more accurate. So most of the reporting, there's several different types of reports that we do. We do an executive summary for my boss, which basically talks about cost benefit, number of fines, reliability. We roll safety into the summary. We tell them what areas we've been has been surveyed and what our plan is. We talk about the exceptions with troubled equipment and a little bit about the criteria. We prioritize it, and then we've got in one case we do some trending, and then we've got a priority trending index that is in there. We use a program besides Maximo called PDIQ. We transitioned out of that program into it from an in-house program. This is the database I spoke of, where any technician can put anything into this program anywhere. The benefit of this is that as they're putting it in, you've got a real-time kind of a dashboard view of what the equipment is, whether you want to look at a substation, whether you want to look at a particular transformer, breaker, whether you want to look at the technician that did it. You can take out any of the data that is in this program and you can slice it any way that you want to. But it allows anyone to take a dashboard view of the condition of equipment. This is an example of what it would look like if you wanted to take a look at, in this case, the West Wing substation and some of the exceptions it talks about. Right there you can see that you've got 3 items in the monitor. You've got an unacceptable condition, and then 4, 5 in the margin. So that's basically what the data looks like, and you can open up. It's a real easy program to navigate in. There's a historical look at what an individual transformer would look like, in this case T1046. You see that there's a priority there called pending, and In some cases, if a technician or an inspector does not know how to prioritize something, they can put that in there. They can attach the report. The engineering, it'll send an email that says you've got something pending, and they can open it up and they can give their insight, experience, and knowledge to it, and then they can establish what the criteria is. It's not mandatory. The technician can establish a criteria if they have enough information, but if they need more and they want to defer it to somebody, they can do that. And as soon as they make a deferral, then a clock starts on it, and it'll send an email to them. And that's one of the measurements that they have as far as things that they have to get done. The deferrals can't sit in a box very long without them answering the question. So a tech exam, after it's been written, is basically the report as the technician puts it in. And once a technician puts it in this case it's an SF6 leak, where the technician goes out to the field and evaluates a breaker, determines that it's leaking. He can link the report on there, and then once he sends that out, it's going to notify the maintenance leader, it's going to notify me, it's going to notify my boss by an email here that says, look, this guy was out there and this is what he found. Click on the link, you can see the report, and that happens automatically with everything he finds to allow everybody to know, like, look, either it's coming or here it is, you need to do something about it, and then there's going to be some follow-up. In this process also, the Maximal work order would be executed, so that would be put into the Maximal system. And something that we don't really talk a lot about is the Maximal, but one of the processes that we go through is every week we'll have a new work order meeting, which I attend, and I'll attend it with the schedulers and the planners and the leaders and the maintenance coordinators, and we can kind of go over, like, look, this is what we found, this is how we prioritize it, this is what our schedule is, and look, what we found here needs to be moved up, or we should be. So we have that communication going on every single week with the company to ensure that what we found didn't fall through the cracks by just assuming that they got their emails. So again, here's another PDIQ assessment report where the technician went out, found a hot spot, and turned it in, and an email was generated that sent it out to appropriate people responsible. All part of communication. I mean, I'm not saying that we want to rely entirely on an email system, because a lot of people don't get their emails, or a lot of people get a lot of emails, but we will have a visual or a voice conversation with these guys that says that if we have something that has to be done, it needs to be done now. Otherwise, we'd address it in the weekly meeting. This is an outage report. One more thing that when I say we do everything planned, we kind of keep our eye on this, because this is every single outage. Most of the technicians on my team will be getting this report. So if we have a nitrogen leak or an SF6 leak, or if we had something fail, both on the distribution and the transmission system we receive, it kind of keeps us focused on what's happening with our system. We all kind of get to take a look at what's happening in real time. So if there is something that we think we could have fixed, or something that we can help with, we'll get this email and we'll dispatch it. Primarily, we'll get that with SF6 leaks, because we don't know all of the breakers that are leaking. But if we see one, we'll go out and we'll get it. We have most of them, but there are a few still leaking. Just another example of a system log. So with all the things that our company can't, that we find, there are some things we decide that, hey, we're going to watch it. And this is basically a view of what we use as a trend report. If we decide that we're at a temperature that we want to kind of keep an eye on something because for some reason our operations won't let us have it, or I mean, typically the reason we would trend something is operation says we'll give it to you in February, or we'll give it to you in January. So when we get a situation like that, we make a commitment to say we're going to put it in a watch list. In the program that we have, we can add it to the watch list, and it'll send you a notification that says, yeah, you put this in the watch list and how often. And when we do that, we start to trend it like this, where they can go in and they can just update the information, and it'll start to tell you where this hot spot's going. This trending report's got some weightings on it, but it takes into consideration how we weight it with material location, its reliability rating, number of customers, key customers, whether it's backbone or it's on a tap, how it's loaded, proximity to the substation, and then the tier rating. Again, we have a 1 through 4 tier rating, 1 being serious with lots of customers and more critical to our system, and 4 being probably a remote transformer that serves very few customers. Feeder load and voltage. In looking at a breakdown, this is specific to our company. 66% of what we find is infrared, 18% visual, and then oil, ultrasound, vibration, sound level kind of fall under there as making up the bottom 15%. I don't think we're unique with these numbers, as aggressive as we are with the technologies. But if you look at our historical cost avoidance, you'll see that it kind of shows some of the similar numbers. I didn't break it out by percentage, but it's pretty consistent with what we find versus what the cost benefit is. I put the slide in here to point out that acoustical is a whole lot higher. We don't find a lot of things with acoustical on but when we do find it, it's a transformer, and it really has a lot of value from a cost benefit standpoint. So this is a Pdm Tech Summary that shows just a 12-month kind of a tracking sheet as to what we're finding, what we're finding it with, and how much it kind of adds up to be that $5.3 million this year as far as cost benefit. And that's 8 technicians out there working every day. So this is a breakdown for this year on cost benefit. Again, acoustical has paid out a higher dividend than thermography, even though thermography makes up 66% of our finds, which is kind of a unique number. I don't think that there's a consistency between how much you find and what the cost benefit is from year to year. If you wanted to run that, it would be all over the place. It just kind of depends on what you're finding with any particular technology.
Okay, gentlemen, I'm sorry to have to interrupt. We need to keep it on time so we can have some time for questions. So thanks again, Scott and Wes, for the presentation.